All right, folks, we'll bring you another interesting topic today. Today is about percents. We're going to look at percents and then we'll look at ratios and proportions and how those three topics related to how they are related to decimals and fractions. Notice that the idea of percents is everywhere. The idea is everywhere. Everything we do. If you walk out of your house to go buy gas or to go, walk or to go eat in a restaurant or to go vote or, buy a particular brand of cell phone or a particular brand of a vehicle, there's the idea of percent is there. It's involved. So before I continue, please, I beg you to subscribe to my channel, like and share this video, leave comments and questions under the video. If you leave any questions, I will answer them. If you need help to help your kids in school and you have questions, just leave it under the video. I will respond to you. All right. All right. The first, see the picture here. The first picture on the top left corner represents, sales taxes. When you go and buy something, the assess sales taxes on you, as long as it's not food. And then look at the one below it. This one here. This is about taxes you pay, during payroll. When you, depending on the type of job you do, there's something they call payroll taxes, right? And then look at this picture here. The one bottom right is about waiters, right? When you eat in a restaurant, they expect you to pay certain percentage of the cost of your food to the waiter as a tip, right? Now notice what I said, percentage. So the word percent and percentage are used interchangeably. They mean the same thing. I will get to that in a minute. So yeah, when you go to a restaurant, you give a waiter some tips. Usually it's about, they say it's about 15%. I don't remember, 1.5 or 15% of the cost of your food. And then look at this picture here, the one on top, right top. It represents a lot of stuff, like when they can ask people what kind of brand of phone are you likely to buy, iPhone or Samsung phone or Apple iPhone, stuff like that. Some people are likely to buy Apple, or they're likely to buy a Samsung phone, right? Smartphone. Or it could be about voting. I just designed that. It could be about anything. It could be about voting. They say which party are you likely to vote for, Democrats or Republicans? Which candidate are you do you prefer to vote for? You see, everybody got their choice. Or they can say which brand of car are you likely to buy, American car or Japanese car, SUV or regular vehicle, a truck or a vehicle. So something like that. That one is called survey. They survey people, see where their opinions, where the opinions are in certain issues or buying certain products. So all that stuff is based on percentage, man. They're all based on percentage. All right? But now I'm going to have to define what is percent. The natural question is, what is percent? Before I continue, please subscribe to my channel, like and share this video, leave comments or questions under the video. What is percent right there? Percent. The word percent consists of two words joined together. This right here, broke it up. per. Per means in every. Cent means 100. So I will get to that in a minute. I will get in details. I will explain that word cent in details in a minute. So percent basically means a part in every 100, right? And then the word cent is like the word, it comes, so it means the same thing. It has the same meaning as the word, the cent you see in the word centuries. Centuries are like, hundreds of years, right? Another way to look at percent is I usually think of it as over a number over 100 or a number out of 100. So the key is 100. When you talk about percent, the key is 100. So there are different signs they use to represent percent. This sign here is the most common one. You see these two here in some books or documents, some financial documents. You see PCT or PC. That's what they use in some financial situations. You see. All right, let me give you some example. When you see a number like they say 85%, basically that means, given the division I gave you over there, above there, that basically means 85 per 100, right? Another way to write it is 85 over 100. That's all that means. That's all, that means. Another general way to say it is if there is a number A percent, right? That number, that thing stands for A over 100. So that's where you remember that. It's all about 100, man. And basically it's a fraction. A fraction that is always divided, a number divided by 100. That's all. So let me give you a deeper example, that everybody knows. Everybody knows about these examples. Now consider the images you see in there. The first one, this one here, everybody knows what is a penny. A penny is 1 cent. 1 cent. And then look over here. And then this one here is, the one right there is 5 cents. Alright? And then this one here is called a 1 dime, which is 10 cents. American money is, broke down. The units, the fundamental units are in cents. I will explain that further, but I want to show you all of them. This is a quarter. A quarter, it says a $quarter or quarter of a dollar. A quarter is 25 cents. And then look at a dollar. You see a dollar there? A dollar is basically 100 cents, right? So these this is how they designed the American currency, to make it easier to use or manipulate during transactions. So they put it in 1 cent, 5 cents, 10 cents, 25 cents, and then $1, is 100 cents, right? Now check this out. $1 is equals to 100 cents, right? Okay. If you look at, look at one cent, and then ask yourself, what is the relationship between 1 cent and $1? You notice that 1 cent is the same thing as 1 over 100, or the same thing as 1%. That's 1 cent means 1%, right? We're gonna get deeper in there, but I want you to think about this for a minute. Think about 5 cents, the money 5 cents, the coin. What does that represent? It represents it represents 5 over 100, which is the same thing as 5%. All right? And then check this out. What is a dime? A dime is 10 cents, right? What does that represent? That represents 10 over 100. The same thing as 10%, right? It's 10% of $1. All right, so what of a quarter? A quarter is 25 cents, right? 25 cents is the same thing as 25 out of 100 cents, which is the same thing. We usually write it 25%. We write that figure there as 25%. You see? But I'm going to get into that in more details, as we go. That way you see what your money represents. Now we'll begin by doing different kinds of conversion. To convert percent to fraction, basically what you do is, because percent basically, like I said, it means divided by 100, right? So just as long as you keep that in mind, everything becomes very easy to understand. So if we have any number, let's say I'll call it n percent, it's something as is equals to that number over 100. That's what that means, right? Then you have to reduce it. You have to write it in form of reduced fraction. That's all. In other words, fraction in reduced terms, right? Which we have done many times in the past. So I will give you examples. Examples will help you understand what I'm saying. Now I'm gonna start with all the money. See, remember we went through all the American coins. Let's use them as an example. That way it will make more sense to a lot of people. Let's say we have one. Remember 1 cent is the same thing as 1%, which is the same thing as 1 over 100, right? So there's nothing to convert it to. It's already reduced. So it's in reduced terms. So just 1 over 100, right? Now, what of 5 cents? 5 cents, remember we say it's 5% of a dollar. Because it's why? Because it's 5 over 100. That's a fraction there, but we'll have to reduce it. You write it in reduced form, it will be, you take 5, divide by 5, you get 1. Take 5, divide that, you get 20. So if you reduce it, it will be 1 over 20. That's the reduced fraction there. A fraction in reduced form. Now, what of a dime? We say a dime, 10 cents, is 10%. It's the same thing as 10 over 100. We're dealing with 100 in denominator, right? It's 10 over 100, which is the same thing when you reduce it. The same thing as you cross this out is same thing as 1 over 10. Sometimes people have problem with 10%, but I will explain that later. What of a quarter? Quarter is 25%, right? 25% of a dollar. You write that in fraction form, it's 25 over 100, right? You can reduce that, it becomes 25 divided 100 is 1 over 4. See, that's 1/4 of a dollar. It's a quarter. You remember, that's why it's called a quarter. The word quarter means 1 over 4, right? So, if you get confused, think about money. Think about your coins. Your coins will help you to remember what is going on. So suppose that then I give you, these are the things right? Suppose I give you 75%, say reduce that to a fraction. Basically, you do the same thing. You write 75 over 100. And then you try to reduce that into simple fraction. What you get, you use 5, just use 5 repeatedly, you will get 3/4. That's something as 3/4, right? What's that? 3/4. They said 3/4, right? Because quarter is 1/4. So that's 3/4 right there. What of 100? Suppose I say 100%. Check that out. Do the same thing, 100/100. And that gives you 1. Right? Now, suppose I make it bigger. Suppose I say 140%. Yeah, there's nothing to be confused about. Just do the same thing we're doing. As long as percent is involved, you write 140/100. And when you reduce that out, you reduce all that out, you get 14, right, over 10, or the same thing as 7/5. That's all. Now, what of a figure like 200%? What does that mean? Well, you do the same thing, 200/100. You cross things out, you get 2. That's 2. So that means that, well, let me put it in word. Let's say they say that a company's revenue increased to 200%. That basically means it doubles, because that's what that means. The revenue doubles. It doubled or doubles, whatever, right? It increased 2 times. That's all. That's all what that means, right? The revenues increased 2 times. All right, now let's move on. What of converting percent to decimals, right? Basically, the way you proceed, it's like, let's say we have a number n%. We want to convert that to decimal, right? To a decimal. So the best strategy, if you follow this, you won't make a mistake. So what you do, you remove the percent sign and replace it with a decimal point. Let me write that down for you. Remove the percent sign, and replace it with you replace it with a decimal point. A decimal point. That's the first step. So you do it, you remove percent sign, write the n, and replace it with a decimal point, right? And then the second step, you then move the decimal point to 2 places to the left. You go like that, you move it. If you don't have enough space, if you don't have enough space to move it, you put a 0. Put a 0 like that, you move it 2 places. So this is from here, that's one space, that's another, and you end up here. See, moving it from there to there means you move the one space, you move second space, and then you put it right there. So if you don't have enough digits, just put 0 in front of the number. That's what that says. Okay, so I'm gonna do some examples to help you understand what is going on there. All right, here are some examples. Let's start with those numbers we know, right? We know 1%. We know 5%, which is 5 cents. We know 10%, which is a dime. We know 25%, which is $1, right? So we do this, and then after that we do, let's say we do 7%, we do 178%, and we do 439%. We do all this. To start with this, what do you do? That's you remove first. You remove the right there. You remove it. You write 1. right? And then you move 2 points to the left, which means you have to add 0 here and then move it over here. You can put 0 in the front. See? The same thing here. You write 5, and then you have to move the decimal point 2 places, which is you put 0 here, right there. You can put 0 in the front, right? Some people don't like to put 0, but I like to leave it there. If you don't put 0 on the left of decimal point, it's okay. And then the same thing here. You write the 10, remove the percentage. I'm sorry. You move the percentage sign, and then it's already moved 2 places. 25%. You write it down here. You move the percentage sign. You put the 0 here because it's already moved. So it's 0.25%. What of 7%? 7% is like 5%, right? You write it down here, but you gotta put 0. You go like that. You can put 0 in the front. See? So if you remember, there's two units to the left. Because why? We're dealing with 2 zeros when it comes to percentage, right? Now, what of this one here? 178%, you write this down, and then you remove I've just removed the percentage sign, then you move to 2 places to the left, right there. That's nothing to get confused about. So it's 1.78. You do the same thing. You write 439 without the percentage sign, and you move it right here, 4.39. See? So that could mean anything. The sales increase by 439%. That means it increased 4.39 times. That's all. That's all that means. It doesn't mean more than that. Okay, now we're gonna convert fractions to decimals. The first one over there is the quarter. Remember, it's basically 1 divided by 4. We'll proceed as we normally do. We'll put 4 here. We'll put the division symbol. We'll put 1 here. And then we'll put dot here, 0, 0. You can put as many zeros as you want. Doesn't make any difference. If you need more zeros, you will put zeros, right? And then 4 going to 1, it won't go. You write 0. And then 0 times 4 is 0. Subtract, you bring 1 down. And then you bring this 0 down. Okay, 4 going to 10, you can divide 8. 4 divide 8, you get 2. You put 2 here. 2 times 4 is 8. And we'll subtract. We'll get 2, right? We'll bring the 0 down. And that 0 makes it give us 20 to divide. We'll run 4 through 20 is 5 times, right? And then we'll put the 5 here. And then 5 times 4 is 20. We'll subtract is 0, and then we're done. We'll say 1/4 converted to fraction is this. To decimal is the same thing as 0.25. That's the same thing that they call quarter. Okay, the next one is 10 cents. We want to convert it to decimals. We'll begin write 1 here. Put dot there, put dot here. Put as many zeros as you want. It won't go. We'll put 0, 0 minus. We'll bring 1 down. We'll bring 0 down. 10 going to there. It will go 1 time. 1 times 10 is 10. We'll subtract 0. We're done. Basically, we're done. You can bring that 0 down, but it's not going to do any good because we're done. So we'll say 1/10 is converted to decimal is 0.1. Okay? So we'll keep going. Alright, we'll do 5%, which is, remember, it's 5 cents. It's 1/20. So we'll put 20 here, and we'll put the division symbol. We'll put 1 here. We'll put 0 here. Put as many 0. Put dots here. 20 going to 1, it won't go. 0, 0, and bring 1 down, bring 0 down. 20 going there, it won't go. We'll put 0 and multiply with 0 and 20, you get 0. Okay, you bring 10 down and you bring 0 down, 100. Okay, 20 going to 100, it will go 5 times. We'll put the 5 here, and 5 times 20 is 100. When we subtract, we'll get 0. We're done. 1/20 is the same thing as 0.05. Okay, we'll do another one. We'll do 38/5. We'll put the divisor here. We'll put the dividend here. We'll put as many 0 as we want. We'll put the decimal point to line up. 5 going to 3 won't go. We'll multiply is gonna be 0. And we'll bring 3 down, bring 8 down. 5 going to 38, it will divide 35 to give 7. We'll put the 7 here, right? And then we'll say 7 times 5 is 35. We'll subtract, we'll get 3, right? And we'll bring 0 down. Put it here, give us 30. 5 going to 30, I think it's 6 times, right? Yeah, 6 times. 5 divided that is 6 times. We'll put 6 here. And then 6 times 5 is 30. We'll subtract, it's 0, right? It's 0. We can bring that 0 down, but it's not going to do us any good. Basically, we're done. Once you get 0, that's a clue that you're done. Okay, so then we'll say 38/5, see the same thing as converted to decimal, the same thing as 7.6. And then we're done with that one. Let's do one more and then we'll go to something else. You write the divisor as we normally do. You put the divisor there, 3, and you put the dividend here, 7. You put 0, 0, put the dot here. And then you continue. 3 going to 7, you would do 6. 6/3 gives you 2 times, right? You put the 2 here. 2 times 3 is 6. You subtract. You subtract that, you get 1, right? And then you bring the 0 down. Okay. 3 going to 10, it will go into 9. Go into 9 to give you 3. You put the 3 here. All right. And then you put 9 here. You subtract. You get 1. Okay. So you bring the 0 down. 10. See, it's repeating, right? It will go into 9. Give you 3. 1. Okay. You can add another 0. It's just repeating 0. All right. You go in there 9, 3. So notice what is happening is repeating. We can do this forever. It will never stop. 1. Okay. So when it happens like this, you just stop right there, and then you say. Basically, you say 7/3. It gives you 2.333. You keep going. You can say dot dot dot, or you can say the same thing. 2.3. You put the bar there. See the same thing. So that's the solution there. Now the next thing we'll do, we'll convert decimals to fractions, right? Now the first one there, 0.36. It just the same thing as this, 36/100. All right. Then you reduce it. You get 9/25. Yes. You just reduce that and then you're done. So let's do another one. we'll do 7.6. Will give us 76 over 10. And you reduce that 6 over 10. Are equal to 7, 3 over 5, yes. And then we'll do another one. 9.3 is equals to 93 over 10. Equals to 93 over 10. Okay. So we can do that forever. It's just very simple. Let's do ratios. A ratio. What is a ratio? A ratio is a comparison. A comparison of two numbers. That's all. A comparison of two numbers. It's basically, a ratio is a fraction. It's a fraction. Just a fraction. You end up getting a fraction, right? For example, you can say A over B. You're comparing A to B right there. You can write it as A divided by B, or this is the new thing to you since we started this course. You can write ratio like this: A compared to B. See right there, right? So that thing is read, whether this or that is read, you read it like A to B. A to B. Right? That's how they read that. You can say, what is the ratio of males? A good example, somebody can say, what is ratio of males to female in a particular company, right? What is the ratio of males to females, right? Females in a particular company, any company. So somebody can ask that question, right? So that gives you the idea of ratio. So we can say it's like 60 to 40, right? That means you always pay attention to what the figures mean. It says males to female, right? So that means 60 represent males, 40 represents female, right? So you always pay attention to what the numbers stand for. If you don't do that, then you're gonna end up misinterpreting the figures, right? So let's another way to write that, you can say 60 over 40, right? You can reduce that. It becomes 6 over 4. You reduce it further, it becomes 3 over 2. So that means there's a male to female ratio is 3 to 2. That's what that means. So if you have in that company, it would be 3 males to 2 females. That's all. It's important to understand what the numbers stand for. If you mix it up, then you get the wrong result, right? There's another term I want to define. It's called proportion. Proportion. All right. Proportion is the same thing as it's a ratio. It's a statement that two ratios are equal. That's all. It's a statement. A statement that two ratios are equal. That's what is called proportion. Usually proportion is very, very important, man. If you understand proportion, you can solve a lot of practical problems in the real life, right? You'll see in a minute. It's usually, proportion is usually written like this. Written A over B equals to C over D, where those are numbers, right? So the way you read it is A is to B as C is to D. That's how you read that. That's how they read it. So if you have something like this, 3 over 5 equals to 9 over 15, from proportion you get cross multiplication, right? You can cross multiply. That's what they mean, cross multiplication. Let me write that down. This is very, very important. Cross multiplication. So there's nothing to be scared. It's a very simple concept. You cross multiply. If you cross multiply, that means you take 3, you multiply the denominator of the other fraction right there. It's equals to 9 times 5. That's all. You cross multiply, you get that, right? So that's what that means. It's nothing to be scared of. Very simple stuff. You've probably seen that a lot. You've seen that a lot somewhere. Okay. So let's say I say X is to 16 as 15 is to 40. So the way you translate that is this. You translate it as X is kind of variable. X over 16 is equals to 15 over 40, right? So, and then you try to solve, X is usually called a variable. We're going to get into that in algebra. This is basically an introduction of a lower algebra. You solve it by doing cross multiplication. You cross multiply, you say 40x is equals to 15 times 16, right? Which is equals to 240. 240, then you say x is equals to 240 divided by 40, which will give you, 24 divided by 4 will give you 6. That's the answer right there. So notice something. Notice something here. You have, what we did up there is we had a variable. All right? We'll multiply it by a number. It's equals to then another number, right? And we'll multiply it by another number. So that is what we just did up there. It's just a multiplication statement. There's nothing mysterious about it. We did this many times in the past, and as I'm telling you, proportional problem is everywhere. You can use proportion to solve, or you can use it to solve problems in physics, in chemistry, everywhere. Even in what I call the Q map, how the medications are given. There are proportions there, see? So I will give you 2 examples, then I need to close this down. I'm tired of this thing. I'm sorry, I shouldn't say that. Okay, let me give you 2 examples. Okay, the first example, I'm going to write it down. All right, I'm going to solve two examples to show you the importance of proportions. If you understand proportions, you understand a lot. You can solve a lot of problems. Okay, now, see the problem I put down there? An example. Supposing that in a map of a country, 4 inches represents 50 miles. How many miles are represented by 16 inches? Okay, so this is a proportion problem, right? Basically, what he's saying in proportion terms is that 4 inches is to 50. 4 inches is to 50 miles. as 16 inches, right, is to what? To how many miles? To what? To how many miles? So that's what they're saying. But let me leave it like that. So basically, you have you line it up like this. It's a proportion problem. You need to know what it's looking for. But I will get that in a minute. It says 4 inches is over 50, right? It's equals to 16 is over what? That's why you gotta use that variable. So if you solve for that variable, you get 4x, you cross multiply. You get 4x equals to 16 times 50, right? 15 times 50, I'm sorry, 16 times 50 will give you 800, right? And then you say, you say x equals to 800 over 4. You divide that out, you get 200. So that means you gotta know what the x is. X is you actually represent the number of miles, right? So that means there are we're looking, there are 200 miles in 16 inches, right? That's what we just did. Okay, so basically, what we did, we let x represent, that's what we did in that problem. Let x represent the number of miles. The number of miles, right? I'm hurrying up. Okay, and then we'll solve the problem and we got the number of miles, right? Now let me show you another problem. I already wrote it down. Another example. The ratio of clients. I don't know if some people that watch this, they will laugh. The ratio of clients to program directors in an agency is 38 to 2. Then they ask, how many clients are there in an agency with 45 program directors? Again, this is a proportion problem, right? It's a proportion problem. So basically what you do, you continue as we did before. You don't read too much into the problem. Just know it's a proportion problem. So basically you set it up like this: 38 to 2. It's the same thing. You are given 45. So you use what you're given to solve the problem. You cross multiply, you get 2x is equals to 38 times 45. Okay, 38 from 45 is you can use what we did before to find this. If you find it, it will be 2x is equals to 1710, right? And then you divide 1710 over 2. You divide that, you get 855 clients. That's how many clients. Again, you gotta know what you're looking for. So X represent the number of clients. If you understand the problem well, you read the problem carefully, but don't spend too much. Don't split hair. The number of the clients to program directors. Clients to program directors. Clients to program directors. And then they want how many clients are there in the agency. See the way they're only giving you 38 to 2. These are clients. They're looking for clients. You put it here and then you put the number of program directors down there. You cross multiply. There's nothing to be scared of. You gotta read it carefully, but don't spend too much time over reading it. Then you make mistake. Alright, please subscribe to my channel. If you have any question, leave it under there. Like and share this video. Thanks for coming.